a case study on Rubygems. Now, what is Rubygem? The Rubygem is a tool which manages Ruby application packages lifecycle from creation to distribution. If anyone has ever worked with a Ruby-based application, chances are that they have used Rubygems to manage dependencies, libraries, or even frameworks, like the Ruby on Rails framework. In the case of Ruby, the default package manager is called the Rubygems. This program has been distributed with the default Ruby interpreter since version 1.9 and helps with many things from downloading to packaging and distributing Ruby applications, and of course relevant binaries and libraries. Rubygems is very rich and probably one of the most mature package management applications that ever exist. It provides developers with a standard structure along with a standard format to deal with application collections known as gems. Now, what are gems? Gems are simply open source libraries that contain Ruby code and are packaged with a little extra data. Using a gem allows a programmer to use the code within the gem in their own program without being explicitly inserted in that code. Now, what are product assets? Assets generally include hardware, software, and confidential information. Assets should be protected from illicit access, use, disclosure, alteration, destruction, and theft resulting in loss to the organization. Some of the product assets of our Rubygems package manager are listed below. The first is the rubygems.org. If an attacker uploads a malicious gem into the package manager to be utilized by another user, the integrity of the entire Rubygems may be jeopardized. Gems. A break and change in a Rails gem could make a hacker gain access to a lot of servers. Ruby on Rails framework. A vulnerability with rubygems.org will allow hackers to execute code on the server, causing the entire framework to crash down. For example, Twitter is built using the Ruby on Rails framework. A vulnerability with rubygems.org will allow hackers to gain access to that website, often causing the entire website to shut down. The fourth one is the hosted website data. Vulnerabilities in gems used for creating websites using the ROR framework could leave websites susceptible to attackers. The websites may be tampered with, made unavailable, and used for conducting malicious activities routed through the hosted network. User credentials. Obtaining the account's password becomes a hacking exercise if a threat actor knows the username. A threat actor will typically target a systems administrator first, since their credentials often grant them immediate access to sensitive data and system. User data. Most websites today store user data of some form. This can range from personal content such as pictures, videos, text, along with sensitive records such as phone numbers, social security numbers, etc. Any vulnerability in this gem results in exploits targeted specifically at gathering this information. Client PC. Gems could be manipulated to gain access, log data, or cause unusual behavior in the client PC. Leaving backdoors intentionally is a known issue. Server. The server on which the website is hosted can be compromised because of gems with vulnerabilities leading to denial of service or data breaches. Because these assets can cause an entire system to shut down or break down, they are labeled as product assets and they should be protected at any cost. Rubygems are vulnerable to several kinds of threats. The first being is the supply chain attack. Organizations are indirectly threatened by these assaults because they target third-party vendors who provide them with software or services. In this instance, there is an implicit trust between the software provider and their customers, which is precisely what software supply chain attacks try to undermine. Cybersecurity experts at Reversing Labs revealed over 700 malicious gems packages written in Ruby programming language that supply chain attackers were caught recently distributing through the Rubygem repository. The second one is typo squatting. Typo squatters use misspellings of popular names to misdirect victims into using the wrong thing. Though it's been a problem for websites for years, it's becoming an increasing issue for software developers too. Rather than reinventing the wheel by writing their own code to handle common tasks, They write it once as a software package and upload it to repositories. These repositories contain thousands of packages for developers to download. The upside is that it accelerates software development. The downside, developers don't often know exactly what those packages are doing. Security researchers at threat detection company called Reversing Labs found typo squatters had uploaded a malicious package in Rubygems. One can install a Rubygem package by typing gem install followed by the package's name on the command line. Attackers take advantage of this by copying a legitimate package, inserting some malicious code, and then uploading it again with a similar name to target novice programmers. In one such case, the threat actor had engineered the package to steal victims' cryptocurrency.
Now I'm going to be talking about the architecture of Rubygems. Essentially, if you refer to the case study, this is the second chapter, the design analysis. Now let's talk about the architecture. Rubygems is divided into various subsystems. There are many different subsystems, but we were going to try and focus our attention on a few of them, as some of them are not really that useful or are not relevant to what we were trying to investigate. So we have looked into three of the major subsystems which essentially hold most of the functionality. We have rubygems.org, which is basically the website and the website's infrastructure. We have the gems, which is basically a Ruby wrapper for the Rubygems website. And we have Rubygems itself, which holds all the actual code related to working with different packages and trying to implement the various methods that we have when it comes to package distribution and management. Now let's take a quick look at the first subsystem that we are talking about. That's going to be rubygems.org. This is essentially it's a Rails framework, and as you can see with the picture that I've provided here, the user sends out a request, and that request is essentially rerouted to the CDN, the Fastly CDN, which is a content delivery network, and eventually it is passed on to the once the delivery is made, a log file is created and passed to the S3 bucket that is queued up through SQS, and then eventually passed on to the Postgres SQL database, where the counter is updated, and that is then eventually passed on to Rails, which makes the whole changes to the front end of the whole website. Now let's look at the next subsystem. This next subsystem is of Gems, which is basically a wrapper for the Ruby website, the rubygems.org. It has a few sub-modules in it. They are client, configuration, gem editor, not found, request, and version. This is just basically a wrapper which is it just helps users get information from the website about the various different gems. We have seen a bunch of different vulnerabilities expressed where more information was disclosed about a certain gems functionality than required. Usually users are doing a set of functions like gems.most downloaded to get an idea of the top 50 most downloaded gems, or they can do some gems name and then they could get information about the gem, when it's created, how big it is, and etc. Now let's look at one of the most important subsystems of Rubygems, which is also named as Rubygems on GitHub, and this deals with one of the most important and essential functionality related to the package distribution and management. Essentially, we can break it down into creation, installation, maintaining, and uninstalling. There's way more to it, but for the purposes of presentation and relevancy, we are looking at only these four. When we're talking about creation and installation, they're very specific, and in fact, even maintaining and updation, there's a lot of important security mechanisms that go through with this, since almost all of our information is sent over the internet via the HTTP requests. Hence, we are able to see a different bunch of authentication and encryption modules present inside this particular subsystem. Here's the threat model that we have created. It's fairly large, which is why we had to divide it into two different sub-diagrams. First sub-diagram relates to the working of rubygems.org. This is included into the threat model because we have seen a decent number of vulnerabilities expressed here. This is the second part of the threat model. It's the second sub-diagram. This includes the functionality related to Rubygems, and we have seen a very large chunk of vulnerabilities exposed from this particular subsystem. Also, most of the security encryption mechanisms reside in this subsystem, which is why we have included this. Now let's look at some of the vulnerabilities that will arise when we switched into the analysis view. The first one was that we thought was actually relevant, and we tried to mitigate it, was of the type information disclosure. Here we have the improper data protection of the file system, which, like I said in the last slide, contains the checksum values required for each version, and this is and if an attacker were to gain access to this particular files, they could change it, causing intense disruption. We can try to add more increased security using some cryptographic techniques to stop just any access to the file unless it's approved by the master node. The next one is about denial of service. We are now looking at some of the denial of service of rubygems.org, where if too many requests were to be passed to the website, we were to see a potential crash, because on a regular basis we don't really see that many installation and updation requests, but if a heavy number of requests were to be passed in a very short amount of time, that would cause a little bit of disruption, and this can be included in the code and forced for the system to hold or queue up the remaining requests.
Now let's talk about code inspection. In our code inspection, we were not able to find new significant vulnerabilities in the Rubygems code, so we decided to use the ones that were fixed and logged in CVEs. The files we selected are the ones that have high risk of security risks. The file that we chose for this code inspection is test.gem package, which is found in the test directory of Rubygems. This source code is used for testing the gem packages. The vulnerability that from the source code affects the integrity of Rubygems. The error in this code was when users added new files to the destination, it will delete the target destination before making a new directories or files. This vulnerability affects the Rubygem version 2.76 and 3.02. The type of vulnerability in this case is directory retrieval. So because of that, it leads to data loss. So this vulnerability was registered in CVE 2019 20 to 8320. This is the sample code for this vulnerability, and they were able to fix this issue with this update. The next file that we use for this inspection is server.rb. The source code is used to start HTTP server on the given port, and it serves for browsing of gem specific files for installed gems. This vulnerability affects the integrity of Rubygems and had a moderate security impact. This source code is found in Rubygems directory. The vulnerability type in this case is cross-site scripting, which affected the Rubygems version 2.29, 2.3, and 2.5. This vulnerability in gem server displays the home page attribute that can cause cross-site scripting. This vulnerability seems to be exploitable if the victim browses to malicious gems on the vulnerable gem server. This vulnerability was registered in CVE 2018 100078. This is the sample code that we found from GitHub for this vulnerability issue, for this error code, and the fix for it. The last file that we selected for the code inspection is safe.yaml.rb. The source code is used for safely loading YAML specification from the gem. This risk affects the confidentiality, integrity, and availability of the source code, and also it affects the other applications that process gems on the server. This vulnerability affects Rubygems version 2.00 and 2.613. The vulnerability type in this case is execution code bypass. As a result, YAML deserialization of gem specifications that can bypass class whitelist. The serialized items that have been specifically designed can be leveraged to escalate to remote code execution, which results denial of service. This vulnerability was registered in CVE 2017-0903. This is the sample code that we found from GitHub that used for loading YAML specifications. Based on prior vulnerabilities discovered in the files, we came up with this recommended checklist of security risks in the Rubygems project. The first one is domain-specific concerns. Rubygems validates versions with irregular expressions, which can be vulnerable to denial of service. The other one is coding mistake. In some cases, clients can be directed to a separate server, which may lead to fetch gems and make API requests against Rubygems. Other past vulnerability mistakes that were made in this project were when decompressing TAR. They used a symlink to delete their directories. There was another past vulnerabilities due to installing malicious gems can lead to arbitrary code execution. and errors that have a vulnerability to escape sequence injections were also the past vulnerabilities in Rubygems. The other concern is design concern, which is there's no well-established design for security protections while downloading gems, so users can download malicious gems. The other concern is availability concern. Users cannot tell the difference if there is any change or update on the repositories. The code of the gem can run in the context of the application when it is installed. So this can cause security implications on the server.
Now let's talk about the conclusion we came to after going through this case study. We looked at Rubygems from a security standpoint and try to understand what's going on behind the scenes. We're able to apply the concepts that we learned in our class. We explored some vulnerabilities and tried to understand the history of the vulnerabilities and the system. Explored the architecture and created threat models to understand the architecture better. And then we overall feel that the software is stable and in good hands. Overall, in the past years, the vulnerabilities are less, and a study shows that Ruby has lesser number of vulnerable packages. And thank you so much for watching. This is a list of the references that we have used.